So here is an example of a quadratic inequality in two variables, and this is how it's commonly presented on a standardized exam, where the terms are sort of all over the place and there's no real understanding of what's going on until you isolate y, so that you can see the equation of the curve of the quadratic. Okay, so going ahead and isolating y, I'm just going to throw that negative 56 to the other side. And then I'm going to have to divide by 2. And I'll put the x squared term first. And because I don't like negatives on my coefficients of x squared, I'm just going to factor that negative out. So I have 2x squared plus an x and a minus 28. And this is going to factor to a 2x and an x will make it x squared. Okay, I got to break down this positive x into two numbers that are going to multiply to 56, add to 1, so it's 7 and 8. Okay, and if you just think about what's going to be the common factor that comes out of these two guys and these two guys, you can see that you'll end up with a 2x, a minus 7, and an x plus a 4. So essentially I've solved for my x-intercepts here, x equal to 7 halves. Which is just, I believe, 3.5, and x equals minus 4. So these are my x-intercepts. So then when I go to sketch this graph, I note that the inequality sign is strictly less than. So what am I going to have to do is I'm actually going to have to draw a dotted line quadratic. So okay, and then if I want to find out where is the y values, where are they less than this curve? I hope it's obvious that it's going to be all these values underneath the quadratic like that. So that's the solution region. And if you're unsure about that, you can always just take a test point. So say take this test point of 0, 0. Okay, take that origin as a test point. 0, 0, it's inside my region that I am claiming to be my solution. So if I plug in a 0 for y and plug in 0 for x, okay, the inequality should turn out true. So is 0 less than negative 28? And that turns out 28. So yes, it is. So that is a quick check. Just take a test value and see if it satisfies the inequality. And if it does, that's your region. If you've made a mistake and this inequality turns out to be wrong, then just shade the other region.